And welcome back, and we're back with the 5 most difficult questions. Again, 5 most difficult is a bit of a subjective thing, but I basically looked at the last 5 questions. I've taken one of them out and tried to pick the 5 that represent different sort of topics. Anyway, let's just jump straight into the first question. So the first question is clearly a algebraic fractions question, and moreover, it is a show that questions, which means you need to show detailed algebra which meets a set of requirements. So if you are really good at maths, in a weird way, this question's harder for you because you need to make sure you show more, not just assume it can happen without it. So with that in mind, then let's just jump straight in. So what do I need to do? So I need to simplify this thing here in order to, and what's nice about this question is it gives me the format I need to answer in. And it also tells me that k is going to be an integer. Let's look at what I've got. So the first thing I'd notice is this has a lowest common multiple of 10xy. So I'm going to change everything to a denominator of 10xy. Well, this one already has a denominator of 10xy, so it's just 6x minus y. This one here, I need to multiply by 5y, so 1 times 5y is 5y. It's fairly easy so far, so I'm just kind of doing it in one go. Then this one here, now the thing to note is that's a negative. And then also I need to multiply all this by 2. So it's minus 2 times 2y, which is minus 4y. And of course, the bit that everyone gets wrong, which is a minus and a minus, so it's minus 7 times 2 times a minus, which is plus 14, and that gives me plus 14x, not y. Change that to an x. Okay, so I'm fairly happy with that. Now again, because it gives me the answer, I at least know I'm going to be going the right route. Doesn't look anything like that so far, does it? But what I do notice, actually quite helpful, is these things cancel. Now, as I've just done, in fact, actually I'm going to delete that. You need to be really careful of cancelling too much stuff out, because otherwise the examiner can't read what you're doing. So I'm just going to write it underneath. So I'm going to tick these off to say they cancel. And then I've got 6x plus 14x is going to give me 20x. And I've got 20x over 10xy. X is cancel. 20 over 10 is 2. Over y, I've answered the question. K is equal to 2. Happy with that question. Okay, and the next question is clearly a circle theorems question. So ABC points on the circle centre O. Now, because I've got a centre and I've got an angle on the outside, without even reading the rest of the question, I'm thinking angle at centre is twice angle at edge, but come back to that. And it says BA equals BC. Oh, okay, that's interesting. So I know that this is an isosceles triangle here. I'm going to make this into a triangle. So I'm doing what I would tell you not to do, which is I'm kind of going ahead a little bit without reading the whole question. So the question actually says, prove that OB bisects ABC. So in other words, this angle here is bisected here. Okay, so let's think about what I've got. The key about these questions is to have a bit of a think before diving in, especially given the word proves here. So I need to be writing words down. And actually the way I'm going to do this, I'm going to talk to it, then I'm going to write it all down, pause the video and come back and show you what I've written, rather than you watch me write a lot of stuff. So I think my argument's going to be that I've created, I don't want to draw dotted lines, let's draw straight lines, is I've created an isosceles triangle here, because these are both radii. Let's do 3 because they're different, which means this angle here is A and this angle here is also A because, and again, the words are key, base angles of an isosceles triangle are equal. I also know that if this angle is X, then this angle is also X because base angles of an isosceles triangle are equal. And I also know that if this angle is Y, this angle is also Y, again, because base angles of an isosceles triangle are equal. And then I'm pausing. Oh, okay. Of course, I haven't used the thing it told me in the question. The whole key to the question is, because these are equal, it means also, I'm going to do it in green, that these angles are equal. So these angles here are equal. And if these angles are equal, well, that must mean that A plus Y is equal to A plus X, which means that X is equal to Y, which means that OB bisects ABC. I've worked out in my head what I want to do. Now I need to write all that down. So what I'm going to do, rather than watch me write lots of stuff, I'm going to write it down, come back in a second. Okay, you join me back. Now I think I've written too much here, but equally I've definitely covered myself. So let's actually just flick down for a second. So if we flick down, we can see there are 3 marks for this question. So the question will probably be 1 mark for explanations, 1 mark for having sensible reasoning, and then 1 mark for a complete solution. It's that word complete solution. Now, if this was an A-level exam, they'd be really tight. In a GCSE exam, they're just looking for various words. So for example, base angles of an isosceles triangle are equal is what you need to write, not just base angles. Similarly, I've explained at too much depth that radii are equal. That's all fine as well. I don't think you'd have to write that. And then equally, I've pulled it all together down here with a clear conclusion. So again, it depends on how much time you got in the exam, how much time do you have left. Perhaps come back and fill it in later, but at least getting to the point would have got you a couple of marks. You may lose the last mark if you haven't written all the words. You can see, I mean, what did this take me? 2-3 minutes? And that's quite a lot of time in the exam to be writing a lot of stuff down. But either way, that would be a complete solution, albeit a bit over the top. Again, going back to the idea, I've just used a lot of isosceles triangles. Either way, question done. Okay, so this next question, so we're back to some actual maths now. I don't really like the whole solutions proving writing business, so it feels a bit better. What do we have? VABC is a solid pyramid, ABC is an equilateral triangle, so that's the floor, which also means I know the angles as well, so I know that these are all 60 degrees, which probably feels like that's going to matter. M is the midpoint of AB, okay. F is the point on FC, right, so this is a third and this is 2/3. Still haven't got any numbers. The vertex is directly above F, right, so that's going to give me a right angle triangle here. Again, this is what I'm probably in the exam thinking this rather than writing it if I'm really doing the exam. And then it tells me that VA equals VB equals VC. In other words, the sort of the pointy bit up is the same height from everything. And VF equals 8. So I finally actually have a measurement. So VF equals 8. Considering the triangle VFC, I know that's a right angle because it's vertically above, which means that's 8. And VCM, actually that's helpful. I also know that that's 52 degrees. What do I need to do? Work out the side length of the equilateral triangle, ABC, give your answer to 1 decimal place, meaning it's not a nice round number. My theory is work out F to C using trigonometry, then work out C to M using the ratio, and then equilateral triangle, I can use triangles again. Okay, so let's start off. So let's do F to C. So F to C using 2D trigonometry is going to be adjacent opposite. So it's tan 52 is equal to opposite 8 over FC, which means that FC is approximately, well, it's 8 over tan 52, which is 6.2502. I'm going to use a few extra decimal places. So 6, that's not what I said, 6.2502. And it's 2503 actually. So let's get that correct. By the way, I'm doing this here so you can see the whole question. Obviously use a space below properly. Then what I'm going to do, remember what I said, so I'm going to work out C to M. So C to M is going to be 3 over 2. So I'm basically ratioing it up. So I know C to F is 2/3. So 3 over 2 gives me the whole C to M times this value here. Now it's still in my calculator. So I'm just going to do answer times 1.5, which gives me 9.3754. And now I've got C to M, I can think about the triangle on the floor, which is the triangle that goes from C to M to B. And then because it's an equilateral triangle, I know that's 60. I've got C to M and I want C to B, don't I? So I want X. So that's opposite and hypotenuse. So it's sine. So therefore sine of 60 is equal to opposite C to M, which of course is what I've just worked out. So 9.3754 divided by X, which I need, which means that X is equal to 9.3754 divided by sine of 60, which I know is root 3 over 2. One of these angles you need to know, which approximately on my calculator is, my calculator says 10.825777943, 1 decimal place, so it's going to be 10.8. Now I suspect, is it centimeters? Doesn't give me any length. Yes, it does, centimeters. 10.8 centimeters. Now I suspect in the real exam, you'll probably actually be allowed a bit of leeway. So some marks are marked accurately, some are not, but 10.8 should get you the marks. Next question. This next question is an interesting one, isn't it? So coordinate geometry, I've got the point P, got the point Q, then I've got the point R. PQR is a right angle triangle. Okay, so let's draw this first. So it doesn't matter about getting it right in space. It just matters about setting up your relative diagram correctly. So R, what is it? PRQ is right angle. So that's my R. I'll call that my P. I'll call that my Q. Again, I don't care about whether it's the correct orientation in space. P, so I have it on here, is 4, 5. And Q is 6 minus 6. And then R as well is K plus 3. And I know this is a right angle. Given it's a right angle, from the possible values. Now that's interesting. It says value. So I'm probably going to have a quadratic. You must show all your working. Right, let's do that. So my approach is going to be to use the only information it gives me in the question, which is that PQR is a right angle. And that means that PR, I'm just going to write it down for you. That means that PR is parallel to R to Q because there's a right angle at PR. Put that as a vector, but it's not a vector. Which means there's a gradient. So the gradient of PR, which is going to be K plus 3 minus 5 divided by K minus 4 is plus 4, multiplied by the gradient of R to Q, which is minus 6 minus K minus 3 divided by 6 minus K is equal to minus 1. Wow, that looks pretty horrible, doesn't it? All right, so this one simplifies down to K minus 2 over K plus 4, multiplied by, well, I've got minus 6 minus K minus 3. If I multiply that by minus 1, I get K plus 9, which means I need to multiply the bottom one by minus 1 as well, which means I get K minus 6. In other words, I multiply top and bottom by minus 1, that's okay. And that equals minus 1. Okay, now you can probably miss out a few steps here, but it does say show all your workings. So you've got to be a bit careful. So I'm going to do the step in between. So K minus 9 times K plus 9 equals minus K plus 4 times K minus 6. I'm not going to expand it in my head in one go, which means let's collect these. So left hand side, K squared minus 2 plus 9 is plus 7K. Minus 2 minus 9, minus 2 times 9 is minus 18. And I've got minus, got to be careful because these are all minus. So K squared minus 2K minus is plus 2K. 4 minus 6 is plus 24. Bring everything to the left hand side. So it's going to be 2K squared. 7 minus 2K is 5K. Minus 18 minus 24, wow, is minus 42 is equal to 0. Now, let's remember what I said at the start. Find the possible values of K. Actually, it doesn't say one decimal place, so it might be an exact value. Not even going to risk it. I'm going to go straight to the quadratic formula. So therefore, K equals minus 5 plus minus the square root of 5 squared is 25 minus 4 times 2 times 42 with a negative making that a positive. And all of that is divided by 2 times 2, which is 4. Let's tidy up the square roots. That's the square root of 25 plus 4 times 2 times 42 on my calculator, which actually is a nice number. It's 19. So 5 plus minus 19, which means it probably would factorize over 4, which is now minus 5 minus 19 is minus 24. Divided by 4 is minus 6. And minus 5 plus 19 is 14. Divided by 4 is 7 over 2. What am I doing? I'm working out the values of K. That's my values of K. So therefore this K equals that, all that, happy with that, question done. And this next question looks difficult straight off, doesn't it? There are only red and yellow counters in a box. So let's write some of this down so it's in my head. 3/5 of the counters are red. So far, so good, which means 2/5 are yellow. Sophie takes a counter at random. Okay. Probability that the two counters are the same color as this. Work out the number of yellow counters in the box. Now, let's keep that in my head. That's what I need to end up with. You must show all you're working against. You can't get away with calculator and solving on the calculator. Okay, let's set up my tree diagram. So I've got red first, and then I've got yellow, and then I've got red or yellow, and then I've got red or yellow. And I want the probability that the counters are the same, which is red and red or yellow and yellow. Start with the obvious. So that's 3/5 and that's 2/5. Then the bit that makes this hard is the initial number of red counters is not 3, it's 3x, some multiple of 3. And the initial number of yellow counters is not 2, it's some multiple of 2, which is 2x. Which means the number of red counters to choose from is going to be 3x minus 1 over 5x minus 1. And the number of yellow counters to choose from is 2x minus 1 over 5x minus 1. Which means that the red plus yellow is equal to 41 over 80. So let's do that. So I've got 3/5 times 3x minus 1 over 5x minus 1. And this one is going to be 2/5, 2x minus 1 over 5x minus 1. Add these together and I get 41 over 80. So basically it's now algebra. This is a pure algebra exercise. Now, I'm going to, obviously I'm a maths teacher and I teach A-level maths. In fact, I teach further maths. I'm going to be careful not to do too much in one go, but equally you have to be willing to do some clever stuff to make this easier. So what I'm going to do is I'm going to notice that the denominator of the left bit, the add bit, is in both cases 5 times 5x minus 1. which means my numerator is going to be 3 times 3x minus 1 plus 2 times 2x minus 1. If you're not sure about that, pause the video, check you're okay with what I've done there. It's important because it makes it easier. And all of that's equal to 41 over 80. Okay, so far. Let's now try and tidy this up a bit. And I don't have a huge amount of space, but let's try and tidy up anyway. So the top's easy. I've got 9x minus 3 plus 4x minus 2 all over 5x minus 1 is equal to 41. Now, where's the 5 gone? I'm going to multiply both sides by 5. So 80 divided by 5 is 16, which means I've at least made it a little bit easier. I'm going to multiply 16 by 9x plus 4x is 13x. And minus 3 minus 2 is minus 5. And 41 times 5x minus 1. Now, as an aside, this isn't going to be a quadratic, is it? It's 1x, there's no squares, it's going to cancel out. And before I carry on any further, I have to get a nice integer answer. Otherwise, I will have the wrong answer because I know that that's the number of yellow counters and that's the number that I need. So let's now expand. Now, just remember, this is a calculator question. I'm going to get a calculator out rather than do it in my head. So 16 times 13 is 208. So 208x minus 80 is equal to 41 times 5, which is 205x minus 41. 208 minus 205 is 3x. And minus 41 plus 80 is plus 14 minus 1, which is 39. Good. This is looking good, isn't it? Which means that x is equal to 13. At this stage, this is where you lose the mark. Because the question doesn't say what's x. The question says the yellow counters. Always go back and remember that. So you'll remember right at the start, I said there's 2x yellow counters. So therefore, the number of yellow counters is 2 times 13, which is 26. Wow. What a question. Really, really good question. I mean, it's the kind of question that I love doing. I know some people don't like them, but make your way through it, cross it out, do it again, you'll get better at it. And that is indeed the last question today. As ever, do let me know how they went for you. Any questions down below, do like, subscribe, but I will start posting these once a week-ish because I'm going to be posting some other stuff as well. And of course, the daily stuff. So it's important you don't just do the hard questions, but just do the daily stuff again and again and again to make sure you stay on top of it. Do like, subscribe. Any comments down below, as I've said already, I will reply to you. See you for the next one.